Overview. All the functions provided by the Flight Guidance System, FGS, are collectively known as the AUTOFLIGHT system. The primary functions are presentation of flight director commands, 3-axis autopilot control including automatic landing, auto throttle and thrust control, wind shear detection and recovery guidance, pitch trim, yaw damper. At the heart of the FGS is the Flight Guidance Computer, FGC. A second FGC may be fitted as a customer option. The primary pilot interface with the flight guidance system is by the Mode Control Panel, MCP, situated on the glare shield. Flight Director, FD. The FGS has a single Flight Director system which may be programmed using the mode buttons on the MCP to provide visual guidance dependent on the phase of flight. The Flight Director on each PFD is selected on using the associated switch on the MCP. This also determines which pilot's navigational systems it uses, which is dependent upon the order in which they are selected. The commands are available as either a single Q, V-bar, or split Q, crosshairs, dependent on customer option. Both presentations provide guidance in both the vertical and lateral axis. Autopilot, AP. The single autopilot system follows the commands programmed through the MCP in the same way as the FD by direct control of the ailerons, elevators and rudders. The autopilot is capable of flying the aircraft from just after takeoff through the climb out and cruise to the descent and performing an automatic landing. Power to the servos and clutches is controlled by the autopilot master switch on the overhead panel. The autopilot is engaged using either of the two autopilot engage buttons on the MCP. Nav 1 allows engagement using the captain's side as the navigation source. Nav 2 uses the first officer's side. Engagement and operation of the autopilot does not require the selection of the flight director. Autopilot disengagement is made using either of the disconnect buttons located on each control column. In an emergency, the autopilot may also be disconnected using the paddle switch on the MCP. Yaw damper. The FGS has a dual-channel yaw damper with limited rudder control to prevent Dutch roll and to help coordinate turns. The yaw damper is selected on and off with the yaw damp master switch on the overhead panel. Operation of the yaw damper is independent of autopilot selection. Auto throttle. The auto throttle system within the FGS, in conjunction with FADEC, enables the setting of the correct N1 by moving the 4 thrust levers simultaneously. The N1 is calculated by the FGS dependent upon the current selected speed, mode of operation and the phase of flight. On the ground, the autothrottle is armed using the autothrottle arm switch on the MCP and engaged by pressing either of the toga buttons on the numbers 2 and 3 thrust levers. In the air, the autothrottle is engaged solely by use of the autothrottle arm switch. The autothrottle is disconnected by pressing either of the autothrottle disconnect switches on thrust levers 1 and 4 or by disarming the autothrottle arm switch. Thrust control system. The TRP provides the interface between the pilot, the FGS, and each of the 4 FADECs. The operation of the thrust control system is described in the power plant module. Wind shear detection and guidance. The FGS has the ability to detect both performance decreasing and increasing wind shear below 2,000 feet radio altitude. Detection of performance decreasing wind shear is indicated by a red wind shear caption and a wind shear call-out.
Wind shear, wind shear, wind shear.
Increasing performance is indicated by an amber wind shear caption. If wind shear is encountered during takeoff and go-around, flight guidance and thrust control is automatically provided to achieve safe flying conditions. With a wind shear encounter during approach, the descent on the glide slope is continued with the autothrottle controlling airspeed. Initiating a go-around provides wind shear guidance. Pitch trim. The following forms of pitch control are provided. Auto trim. When the autopilot is engaged, it will automatically trim the elevator to relieve loads on the elevator. Electric trim. The pilot has the ability to trim the elevator electrically by use of split switches on each control column. This is available whenever the FGS is powered and the autopilot is not engaged. Flap trim compensation, FTC. When the aircraft is in flight and the flaps are selected from 0 degrees to 18 degrees or 18 degrees to 0 degrees, the FGS automatically applies elevator trim to relieve loads on the elevator. Altitude alert. Altitude alerting provides oral and visual warnings when the aircraft is within 1,000 feet of the selected altitude. Once the aircraft has captured an altitude, warning is given if the aircraft deviates from that altitude. System monitoring. The FGS advisory annunciators indicate possible failures within the FGC and the yaw damper and insufficient integrity from the necessary sensors to perform an autoland. Master switches, single FGC. Power to the FGS is applied through the row of master switches on the avionics panel. The switches are Yaw Damp Master. The Yaw Damp Master switch controls the power supplies to the yaw damper circuit within the FGC and the actuator at the base of the rudder. Autopilot Master. The Autopilot Master switch controls the power supply to the FGC and enables the autopilot circuit within the FGC, the servos, clutches and sensors around the aircraft. Avionics Masters 1 and 2. The avionics master switches control power to aircraft navigation and communication systems. These are required for the FGS to have full navigation capability. Master switches, dual FGC. If dual FGCs are fitted as a customer option, the following extra switches are fitted. Yaw Damp Master 2. When 2 FGCs are fitted, 2 Yaw Damp Master switches are fitted. Autopilot Master 2. When 2 FGCs are fitted, 2 Autopilot Master switches are fitted. FGC Selector. If 2 FGCs are fitted, a selector is provided to switch between the two systems. Application of electrical power. To ensure that the FGC finds no faults during its power-up test, the row of avionics switches must be switched on from left to right. To depower the FGS, the row of avionics switches must be deselected from right to left. Again, this will prevent any fault indications within the FGS. Power-up test. When power is applied to the FGS, a power-up test is performed, which takes approximately 45 seconds. The following indications are present during the test. PFD. White dashes in the top left and right-hand corners. FGC advisories, FGC 1 or 2, Yaw Damper 1 or 2, and No Category 3 landing. Flight annunciators, Yaw Damper, Electric Trim, and FTC. When the test is in progress, all FGS functions are inhibited. The result of the power-up test is given at the top right-hand corner of each PFD. Pass FGC 1 or 2. This indication is displayed for 2 seconds, indicating the test has been successful and that all functions of the FGS are operational. All of the fault indications are removed and the following thrust control indications are shown. Takeoff max, PFD, N1 set and N1 bugs, PED, Toga max, TRP. Fail FGC 1 or 2. This indication is displayed for 2 seconds, indicating a soft fault has been found during the test. This is not a complete failure of the FGS. However, one or more of the FGS functions are not available. Indication of the failed function should be displayed on the instrument panels, e.g. electric trim. Continual white dashes. These indicate a hard failure of the system. No FGS functions are available. Flight Director, FD. The flight director can be controlled by either pilot. Either the left side or the right side command queue may be selected as the master. The master flight director is the first one to be selected on, and is indicated by the MA light above the on-off switch. Selection of either flight director queue is indicated by FD on both PFDs. The director on the left side, when engaged as the master, uses VOR1, ILS1, LNAV1, IRS1 and ADC1 to provide lateral and vertical mode guidance. To transfer the handling of the flight director to the other pilot, the current master on-off switch can be cycled or both switches deselected and reselected in order. The director on the right side, when engaged as the master, uses VOR2, ILS2, LNAV2, IRS2 and ADC2 to provide lateral and vertical mode guidance. Flight director modes. The flight director vertical and lateral modes are selected on the MCP and enunciated on the PFD. A green enunciator indicates an engaged mode. A white enunciator indicates an armed mode. The MLS and VNAV functions are non-operational. On initial selection on the ground, the flight director engages in takeoff as the vertical mode and track as the lateral mode. No other modes can be selected below 350 feet. Takeoff mode initially provides a pitch-up command of between 7.5 degrees and 10 degrees. After takeoff, it modifies to command VCEL plus 10 knots or V2 when an engine failure is detected. Before takeoff, VCEL is set equal to V2. Track provides lateral steering commands to maintain the track present at 80 knots during the takeoff roll. As well as engaging upon initial flight director selection on the ground, track mode is also entered when a go-around or wind shear guidance is commanded. Selecting the flight director in flight engages the basic modes of vertical speed, VS, and roll, sometimes known as heading hold. Engagement of VS mode also illuminates ON in the VS button on the MCP. Adjustment of commanded vertical speed may be made using the adjacent thumb wheel. Roll mode maintains the aircraft heading at the time of flight director engagement, providing the bank angle is less than 3 degrees. If the bank angle is greater than 3 degrees, the flight director commands the aircraft to roll wings level and maintains the acquired heading. Lateral. The following lateral modes may be selected using the MCP. Click on the relevant button to view its description. LNAV provides steering commands to fly the flight plan using the navigation management system of the master side. VOR lock. VOR provides steering commands to fly the radial to or from the VOR as selected on the master side. Lock provides steering commands to fly the inbound course of the localizer as selected on the master side. As a customer option, the back course may also be flown. Heading select provides lateral steering commands to fly the heading set on the rotary control. Approach. Enables lock as the lateral mode and glide slope as the vertical mode. Vertical. The following vertical modes may be selected using the MCP. Click on the relevant button to view its description. Level change. Provides commands to maintain the IAS or MAC in the VCell window. Vertical speed. Provides commands to maintain vertical speed as selected in the vertical speed window. Altitude hold. Provides commands to maintain altitude. Approach. Enables glide slope as the vertical mode and lock as the lateral mode. Sync. A sync button fitted on each control handwheel synchronizes the flight director cue and indicated airspeed reference or vertical speed reference as indicated on the MCP to the current aircraft value. Pressing the button synchronizes the flight director vertical mode and is indicated by the FD indications on the PFDs turning white. The lateral mode is unaffected. This facility is only available when the flight director is in the level change or vertical speed modes with the autopilot disengaged. In which modes does the flight director engage on the ground? What is the difference between the vertical speed and level change modes? Autopilot. The FGS has a single autopilot system which operates using the same modes as the flight director. The autopilot has full control of the ailerons, elevators and, depending upon the mode, the rudder. Autopilot engagement. The autopilot can be engaged on the ground for testing but cannot be used for takeoff. Once weight off wheels, the autopilot can be engaged 10 seconds after takeoff. The autopilot is engaged by pressing either nav1 or nav2 on the MCP. This determines the master system to be used as the autopilot reference. AP is enunciated on both PFDs. The autopilot does not require the flight director or the yaw dampers to be engaged. If the flight director is engaged at autopilot engagement, the previously engaged modes remain engaged. If the autopilot master side selected is opposite to that of the previously selected flight director, the autopilot takes priority, and the MA lights transpose to indicate that the autopilot source selected is now the master. Autopilot disengagement. The autopilot must be disconnected before 60 knots after landing, using either of the autopilot disconnect buttons on the control columns. A manual disconnection of the autopilot is indicated by a red AP annunciation on the PFDs and flight annunciators, accompanied by a cavalry charge audio warning for 1 second. Disconnect the autopilot. If the autopilot automatically disconnects due to a fault, or a takeoff is attempted with autopilot engaged, the disconnect warnings are continuous until manually confirmed by pressing either autopilot disconnect button. If the autopilot cannot be disengaged using the buttons on the control columns, an emergency switch on the MCP disconnects the power supplies to the autopilot, the servos and clutches. Parallel rudder. Autopilot control of the rudder is known as parallel rudder and is only available when the autopilot is engaged. It provides yaw control when track is engaged as the lateral mode during takeoff, go-around and wind shear guidance to maintain aircraft balance. Parallel rudder is also engaged during a Category 3 autoland approach to provide drift correction before touchdown. When parallel rudder is engaged, the yaw damper is inhibited and all of its functions are handled by the autopilot, preventing any conflict between the two systems. Why does the MCP have two autopilot engage buttons? What is the purpose of the sync button on the control columns? Yaw damper. The FGS has a dual-channel series yaw damper to damp Dutch roll and to help coordinate turns. The yaw damper is engaged independently of the autopilot. The yaw damp master switch controls the power supplies to the yaw damper circuit within the FGC and the actuator at the base of the rudder. If the aircraft is equipped with two FGCs, two dual-channel yaw dampers are fitted, designated yaw damper 1 and yaw damper 2, both of which are used simultaneously, irrespective of FGC selection. The yaw damper has a rudder authority of plus or minus 2.9 degrees and does not feed back through the rudder pedals. If two yaw dampers are fitted, rudder authority is increased to plus or minus 4 degrees. If the parallel rudder is engaged, the yaw damper is inhibited and the autopilot provides any necessary yaw damping and turn coordination. Following yaw damper failure, an amber yaw damper annunciator appears on each of the flight annunciator panels, and YD1 or 2 illuminates on the FGS advisory annunciators. Following illumination of the yaw damper annunciator, the yaw damp master switch may be cycled once in order to reset the yaw damper. Should the yaw damper indication remain illuminated, the yaw damp master switch must be selected off. Switching the yaw damp master switch off removes the yaw damper fail annunciator, but the YD1 or 2 advisory remains. The deselection of the yaw damper will not degrade any of the FGS functions, but the following aircraft limitations must be observed. Speed must be kept below 240 knots. Care should be taken using the rudder at high altitudes. If a single yaw damper fails with a dual FGS, the remaining system still provides yaw damping, although authority is reduced to 2 degrees. YD1 or YD2 illuminates without the amber YD to indicate a degraded system. No action is necessary. How is the yaw damper engaged? Wind shear detection and guidance. Wind shear detection and guidance is provided in flight below 2,000 feet radio altitude for increasing and decreasing performance wind shear. Wind shear can be described as the rapid deceleration or acceleration of the air mass relative to the aircraft, causing a substantial decrease or increase in airspeed and lift. The aircraft is capable of recognizing both increasing and decreasing performance wind shear through a comparison of indicated airspeed, sensed by the ADCs, and aircraft inertial speed, sensed by the IRS. Increasing performance wind shear is indicated by the illumination of amber wind shear annunciators on both instrument panels. Decreasing performance wind shear is indicated by the illumination of red wind shear annunciators on both instrument panels and an oral warning.
Wind shear, wind shear, wind shear.
Flight director, autopilot and/or autothrottle commands are provided to assist the pilot in recovering from the wind shear condition and achieving safe flying conditions. Safe flying conditions are defined as the cease of wind shear, a climb rate greater than 750 feet per minute, and an airspeed greater than VSEL minus 5 knots for more than 15 seconds. Three distinct modes of operation exist. Takeoff control, toes, approach control, go-around control, gauze. Takeoff. Toes is enabled 5 seconds after takeoff with the flight director and/or the autopilot engaged in takeoff track. If the flight director is not selected, it appears automatically. On encountering wind shear, the appropriate wind shear warning is given.
Wind shear, wind shear, wind shear.
The flight director and autopilot, if engaged, provide pitch guidance to fly the aircraft close to stick shake until safe flying conditions are achieved. The pitch limit indications intensify, and toes track is indicated as the vertical and lateral mode on the PFD. WS max is enunciated as the thrust mode, with the autothrottle controlling the engines to an N1 of 97% and EGT to 649 degrees. During decreasing performance wind shear, a new lateral mode cannot be selected. During increasing performance wind shear, a new lateral mode can be selected without affecting the vertical mode of toes. Once safe flying conditions have been achieved, toes reverts back to takeoff. Approach. Encountering wind shear on the approach initially provides autothrottle speed control with no recovery guidance. The autothrottle will not engage automatically. For performance increasing wind shear, the autothrottle controls the aircraft's ground speed to the selected VSEL speed. For performance decreasing wind shear, the autothrottle controls airspeed to VSEL plus 15 knots between Vmin and Vmax. The wind shear warnings are accompanied by the autothrottle mode turning magenta. A go-around must be performed when wind shear is detected. Go-around wind shear. Wind shear recovery guidance is available when wind shear is detected and either toga button is pressed to perform a go-around, or by advancing any 3 thrust levers fully forward. If wind shear is encountered and a go-around is performed, wind shear guidance is provided as for takeoff wind shear. The pitch limit indications intensify, and gauze track is indicated as the vertical and lateral mode, along with WS max on the PFD. As for takeoff wind shear, during decreasing performance wind shear, a new lateral mode cannot be selected. During increasing performance wind shear, a new lateral mode can be selected without affecting the vertical mode of gauze. Once safe flying conditions have been achieved, gauze reverts back to GA. The wind shear detection and guidance system requires both IRS, both ADCs, both stall channels. If any of them fail, wind shear inoperative illuminates on the central status panel. Pitch trim. The order of priority for trimming the elevator is auto trim, electric trim, flap trim compensation. Auto trim is active when the autopilot is engaged. The auto trim function provides elevator trim tab movements to trim out the loads being held by the main elevator servo. Manual electric trim is available when the autopilot is disengaged, using the split switches on the control columns. Both switches must be pressed together in the same direction to activate the trim. Pressing the switches individually or in opposite directions may cause a fault condition. If both trim switches are operated, priority is given to the first pilot to operate the trim switches. Electric trim is inhibited when the autopilot is engaged. Any auto trim or electric trim faults illuminate the electric trim annunciators on the flight annunciator panels. This also causes the autopilot to automatically disengage. Flap trim compensation, FTC, relieves out-of-trim stick forces experienced when flaps are selected from 0 degrees to 18 degrees or 18 degrees to 0 degrees. FTC is inhibited on the ground when auto trim is engaged or if electric trim is in use. Failure of FTC illuminates the FTC annunciator on the flight annunciator panel. In which modes of flight is wind shear recovery guidance automatically given?